morning, everybody. So, second day, we're going to start with caching. So, over the next 45 minutes, we're going to talk about caching of decoupled sites specifically, and how it's a bit complicated, but if you understand the main concept, it's not that hard and it can be super fast. So, my name is Michael, I'm the CTO of Amaze.io. You can reach me in all kind of different places, and so we run a couple of decoupled sites that have quite complicated caching infrastructures because they get a lot of traffic. And so today I want to show you how we have done things, what failed, what worked really well. And please, if you have a question, we're not that many people, so just stop me immediately and I can answer questions or go stuff into deeper. So I want to first talk about regular caching in general, so we shortly understand caching mechanisms in general. Then we're going to talk into specifically decoupled caching, and then we're also going to talk about CDNs, because everybody's using CDNs today, and yeah, they add some complexity even more, and there are some pitfalls that I want to help you prevent in the future. All right, let's talk about regular caching overall. So this is what I would say is like a regular caching that without decoupled, without CDN, without reverse proxy, just pure bone, if you have a Drupal running, this is the caching that's going to happen. So you have the user talks some HTML or requests an HTML from Nginx and PHP. You see that's actually, so that's our Drupal there, but it can be pretty much any other CMS. The Drupal then talks to MySQL, where all its data lives, and gets them out. Plus, Drupal has an internal cache that can be a MySQL based, or it can be Redis, it could be Memcache, it can be something else. So some kind of key value store. Now, this cache usually is completely transparent to you. You don't really see it on a daily basis. So it's completely transparent, and you also don't really need to worry about perching of it. So because it's internal in Drupal, Drupal creates it and purchases it. And it caches a lot of different things. So Drupal has a bootstrap cache, it has variable caches, it has entity caches, and all kind of different things. As mentioned, they're either MySQL key value, but in order to use it, Drupal still needs to do a full bootstrap. And that's actually the reason why we want to add some other caching mechanisms in front. But so that means it is a bit expensive to actually do it. Plus also it is for authenticated users as well. So Drupal has now the possibility in Drupal 8 that also authenticated users can profit from caching, while in Drupal 7 this was not possible. But as you probably already gathered, it's not the focus of today. We want to actually talk about external caching. So some kind of reverse proxy caching. So let's see how does that actually work. So we have our regular caching that we saw before. Now we want to add a reverse proxy in it. So basically this means we have something between the request of the user to the Nginx, to the Drupal, something in between. And this is the reverse proxy. And it's called reverse proxy because it's not actually the Drupal that talks to the internet and has a proxy in it. It's a reverse proxy because it's reverse between the request that is from the user to the Drupal. So you add something like Varnish in there, and basically Varnish sees every single request. And Varnish has its own caching database. So whenever a user requests an HTML, Varnish checks first, do I have that request in my own cache database, so wherever it stores it? If not, it does the regular request to the Drupal, and then Drupal does all its thing, it creates an HTML site, and it returns it back to the Varnish, and then Varnish decides, should I cache that in my database or not? And if yes, it will forward the request to the user. If it can cache it, it will put it inside its own caching table. And then the next time the same user requests the same page, or another user requests the same page, when a request comes in, Varnish says, hey, I have that cached, I have that request I've seen before. Instead of actually talking to Drupal, I will just return the request immediately to you. So with that, Drupal doesn't even know that it was called. This is the basic concept of reverse proxy caching. And compared to the Drupal internal caching, it is much, much faster. So for these reverse proxies, 99.9% in the world you see today Varnish. There are other solutions, but I would say most of them are using Varnish out there right now. Important though is it is only for anonymous users. That means if there is a session cookie present, if the Varnish sees that this request here has where's mouse? If the request here has a session cookie, Varnish will immediately pass it forward. This is like the default configuration. Yes, you can do authenticated caching, but it's quite complicated. I'm not going to go too much into that today. But so by default, Varnish, if it sees a session cookie, so let's say it's an editor or a user that has a card in Drupal or so, Varnish will pass it immediately. But it's super fast. That's the whole purpose of Varnish, and so therefore it's super specialized on that and it's super fast. Plus, most of the time, the caching, so where Varnish actually stores the cached pages, it's in memory. There are possibilities to put it in files. The problem then it gets slower again, so that's maybe dependent on it. But a lot of times, if the Varnish restarts, it has lost all its cache, and it needs to reload or it needs to warm it again. So basically, the second time on the next request, it will warm it up again. Does that make sense? Anybody have a question for that? How that works? Is the concept of reverse proxy caching clear? Yep. Okay. So now let's talk about perching. So let's assume that we have our warm cache, and now something changes on Drupal. So let's say you published a new node that has, or you updated a node that is used on the start page. Now the Varnish has no idea about that. So the next time a user comes and visits the start page, the Varnish will say, oh, I saw the start page an hour ago. Let me, user, show you or give the cache. And that the problem is the new node or the updated node will not be in that cache. So we need some kind of way to tell Varnish to tell it, hey, stuff has changed, and that's what we call perching. Now there is an easy way to just say, okay, Varnish, please update your cache every 5 minutes, but then you lose the whole idea about the caching, so you probably want to have a really long cache time, maybe an hour. I saw customers that have weeks of cache times, and you want to perch every single time. So this is how that works. So basically it means there is some kind of way that the Drupal over here can tell Varnish, hey, the start page has updated, or hey, that node has updated. Please remove. Come on in, come on in.
Sorry, right? You're all watching. Yeah, exactly. Come up for the next performance review.
We need some way for Drupal to tell Varnish, hey, the start page has changed, the node has changed, so Drupal can remove it from its own cache table. So the next time when a user requests a start page, Varnish knows, oh, it has updated, I need to load the data back again from the Drupal. That's what we call perching. Now, there are many different ways. Drupal 8 has now a new system called cache tags. So basically this means every time that Drupal renders something inside a page, it adds a cache tag to the request. So if you, let's say, have a start page and it shows 3 different nodes, Drupal knows every time it loads that node to show it on the start page, it adds a tag like node column 7 or comment column 1056. It adds that to the cache tag. So it basically creates a list of all the different entities that are part of that request. That's something new that has been implemented in Drupal 8. Then, what Drupal does, it adds all these tags to the header of the response. So basically, whenever that the request comes through here, I add that somewhere, or maybe not, doesn't matter. So whenever the request is sent back here to the varnish, it not only has the whole HTML, but it also adds all the cache tags into the request. And then what varnish does, or any cache does, it not only saves the HTML, but it also knows all the cache tags, so it saves that as well. So the cache system stores them. And now, any time that somebody goes in it and let's say updates the node 7, Drupal doesn't go to the varnish and says update the start page, update the node itself, update maybe that block that loads that node. It just goes to varnish and says, hey, node 7 has updated. Please purge all caches that include node 7. So basically the logic is put into the cache system. And Drupal just says node 7 has been updated. And because every request, every URL, the cache system knows where node 7 is, it can go through and it can purge all of them. So Drupal does not need to know, does not need to create. There was an old way of URL purging. That's mostly what happens in Drupal 7, and unfortunately still many people use in Drupal 8. And that's basically that when Drupal updates a node, it tries to figure out at that time where is that node maybe appearing. Well, definitely on its node page, like node/7, but then you have URL aliases. Then you have multiple languages. You maybe have that node in a view on the start page, but Drupal doesn't really know where a node is shown by itself. So people like added like, okay, yeah, just purge the front page every time a node updates, things like that. And that's really inefficient. It's error prone like crazy. We have so many people that like changes do not appear on the site. So I really encourage you, do not use URL purging anymore. Use the cache tag system. It's much better, much easier to use, and you're going to be much, much happier how to use it. Any questions so far? Good. Okay, as we saw now how regular caching works, okay, we want to go into the good stuff now. So let's actually look into decoupled caching. So, if we have that in mind, we go over to decoupled. This is basically how the decoupled part works. So what we have here, we not only have our backend with the Drupal and the varnish, we also have a front end now. So we have another layer with a server-side rendering Node.js, and that each request goes through. So how is the process actually? So the user makes a request to the Node.js. In between that request, we inject a varnish again. So the varnish will see the same thing. Node.js will say, we'll do server-side rendering, and we'll do some GraphQL requests to the Drupal while that's rendering all that stuff. Now, that GraphQL request, we inject another varnish in between, and so the request goes to Drupal, and Drupal does all its thing. It does then talks to the database, blah, 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 blah. It creates the response. In this time, it's not going to be an actual HTML page. It's a JSON response, a GraphQL response. Works the same way with JSON API or any other API systems. In this case, we just have GraphQL. It returns it to the varnish. The varnish will return it to the Node.js. The Node.js will render its whole page, so a full HTML, CSS, JavaScript page, and will return it to the user, again through the varnish. So basically, this is completely cold caches where no request has been happened so far. So it goes through the whole stack and goes back. Now let's assume we have a second request. The second request goes from the user to the varnish to the Node.js. Now let's assume the varnish, the front-end varnish has still a cold cache, so it did not. But what happens is now the GraphQL, the varnish on the backend that has a warm cache, now we'll actually do a GraphQL request. Varnish says, hey, I've seen that GraphQL request before. I have it in my cache. Here you go. So the Drupal is not used at all anymore. So you will have super fast GraphQL requests from the Node.js to the Drupal. Now let's go further, and let's say another person even visits that page, and the same that user visited, and the user will go to the varnish, and varnish says, hey, I've seen that URL already, I cached it, I will return it to you. immediately. So the whole stack, not even server-side rendering, not the Varnish backend, not even the Drupal, no database query at all. It goes directly to Varnish and comes back. So that's the best case you can have. Now, this whole thing is actually an isomorphic application. That means after the first request is sent to the user, inside the browser of the user, the React or Vue or whatever you're using is booting up and will realize, oh, I can do GraphQL requests directly to the backend. I don't need to talk to the Node.js anymore. So what actually happens is the user that now is a full-fledged React app will do GraphQL requests directly to the backend and will do them to the backend by itself. Now, the same thing happens again. If that request has never been used or never been done before, the Varnish says, I don't know anything about it, I will pass it on to Drupal. Drupal does a thing, sends it back. Varnish will cache it in its database. And the second time that Drupal comes, the second time the React does a GraphQL request, it does the Varnish. Varnish will say, hey, I have that already, passes it back. So the end goal is basically that every single request is cacheable by some kind of reverse proxy. And the Drupal or the Node.js, which is doing the really heavy lifting of rendering and whatever, and Drupal and parsing and permissions and whatever, is all cached. And this is why we have a Varnish here as well. And I've seen many applications, they only put the Varnish on front here, which, yes, makes your site faster, but especially if your application does GraphQL requests by itself, you also want to have a Varnish in here. Because especially with now dynamic websites and all these things, the first request only has the whole HTML, but every single other one is the GraphQL, and that's where a lot of the consumption, a lot of the processing happens.
Does this require persisted GraphQL queries?
We'll get there.
Okay.
Yes, persistence and all that fun. Let's assume every of these GraphQL requests is cacheable. But does this make sense? Does everybody understand why we want two Varnish in there? Why just putting a Varnish here does not solve problems here, or just putting a Varnish here would cause problems there? Yes, question?
Yeah, it makes sense. Just with the GraphQL cache tags, is that just Drupal 8 cache tags out of the box? It just works?
Yes. We'll get there. Cache tags in here shortly, yes. Okay. So we learned we have two cache layers, one on the front and one on the back end. And yes, it only really works with cache tags. Because, and that's the important part, both cache layers need to be perched. So if we go further down here, let's talk about perching. So if, let's say we go back to our example before, our node 7 that is used on the start page or somewhere is changed, we not only need to tell our Varnish on the backend, like we did before with just Drupal, that hey, any GraphQL request that has node 7 in it, now please perch. We also need to tell the front end, because that maybe fully rendered the page with node 7. And this means, and we see that up here, Drupal will return cache tags in GraphQL. That's part of the module. If you use a GraphQL module, cache tags will be part of it. They will be sent. But the Node.js, or first thing you need to do is you need to tell Varnish to forward the cache tags. Many default Varnish configurations remove the cache tags, and that's fine, because on this side here, on this side, you don't need the cache tags over here. They're not needed. But we need them on the decoupled because the Node.js needs to get these cache tags, plus it needs to forward the cache tags into the Varnish at the very front as well. So because that Varnish needs to know that the request has, for example, node 7 in it. It needs to know this because then the perching, the Drupal down here, will connect to both Varnish and say, node 7 updated, please perch all caches with node 7 in it. And if you only do that one, you can perch as much as you want because the Varnish up front has no idea that's just something has changed. And so that's where the cache tag system really comes into play. If you try to do any of this with URL-based perching, I don't think that's ever going to work. So that's where the cache tag system actually really strikes, because you can forward these cache tags through the headers, and all different caching layers can use this. It definitely makes sense to tell that varnish out from there to remove the cache tags, because the user doesn't need to know about them. Drupal can never talk to the user and tell, hey, the cache has updated. That's not going to be something that's going to happen. So it makes sense to remove it over here, but if that varnish needs to forward it, and also the Node.js also needs to forward it. Yes?
Is cache tags specific to Drupal only, or?
No. So cache tags is not specifically to Drupal only. It's a common feature set of any CMSs out there today, that we pretty much agreed how these cache tags are now working, and we will go into the CDNs and stuff, they all support that. So like Varnish out of the box supports perching via cache tags. It's basically perching by a header. At the end, it's just an HTTP header, that's it. Cool, okay. So now, let's go specifically to GraphQL. So for anybody that ever has run GraphQL and have used GraphQL and run a request, realized that it does post requests. Now, the reason that it does post requests is not that GraphQL likes post. The problem is, as GraphQL has the understanding that the front end or the requester tells the API what data it wants, that request can get really easily very, very big. Which means you need to somehow pass that request into the API. Now, yes, you could all URL decode it and throw it into the actual request, but there's a max length. I'm not sure where it is exactly, but I think it's maybe 4K or so. So it's really easily that the GraphQL request is too big. So that's why GraphQL by default falls back to post requests. Now, if you read the HTTP spec, nowhere it says post is not cacheable. But unfortunately, because post is usually used to create something or to update something inside an API, CDNs and even Varnish in older versions said we never cache post. If I see post, I immediately pass that on. That's not cacheable. That's technically not true. Because post can also be used to request a lot of data. But unfortunately, that's what it is. So, if you have GraphQL and you put a CDN in front of it and you do post requests, I'm pretty sure your CDN will just never cache this. And I've seen sites that have this perfect CDN and GraphQL and they don't cache. So, what is the solution? It's called query maps or persistent GraphQL, or there's a lot of different ways. So basically what you want to do is we want a GET request, but because the GET request is way too long, we want to have a known between the front end and the back end. We want to create a knowledge, like something like a knowledge base or the query map, where the front end and the back end agree what requests there might be. And how does it work? So basically the front end knows every single GraphQL query that is ever be possible to be created by the front end. And it knows that because it has access to the whole code. So there's some kind of process in there where the front end can generate a query or a JSON file basically of all possible GraphQL queries. Then what it does, it writes that into a JSON files and gives each of the query an ID. It's just query 1, query 2, query 3, query 4. And then the whole query map is hashed, and it has one hash. And we'll see that later, it's just a hash of a couple of numbers. And then the front end passes that query map to the Drupal. So the front end says, hey Drupal, I have a query map for you. Please store it for me. I will use it later. And that can happen either via file, or Drupal has an API, so you can talk directly to the API. We have customers that upload them to S3. It doesn't really matter how you code, like how that file is passed. It just somehow the front end needs to pass it to the back end. And then, when the front end comes and does a request to Drupal, instead of sending the whole GraphQL request, it just says, hey, backend, remember the query map that I sent you? I would like to have number 3 of that query map. And that fits perfectly fine in a GET request on top and is super small. And now is so let's actually look how this works. So we have here an actual site running. It's a site that has GraphQL in it, it's a React front end, and so if I look at the actual GraphQL requests that are happening, so let's say I click on here, we can see that the request URL goes to backend.paraplegie.ch. So this is the backend request. So my front end, the React, does just a GraphQL query directly to the backend, and it says, okay, make a GraphQL request. It says it passes it some variables, so that's important. Even though we have a query map, you don't need to create every single GraphQL query with every single possibility of every single path, because GraphQL has variables. So inside the query itself, you can still pass in stuff, and so and then it tells it, hey, I have version. This is the hash and the ID 12. So that's the hash and the ID of the query that Drupal passes to the backend and says, hey, please give me that one. And then Drupal will check the query map, will find that. Now let's actually look at how this query map works. So in this site, the query maps are actually added to the Git code. So while the whole thing builds, it adds it to the Git code, and Drupal has access to that repository. And that's possible because our hosting solution deploys the front end and the back end at the same time, and they can actually share data in between. So while the front end is building, it creates some data, like it runs a query builder for these query maps, and the Drupal requests that data from the front end while it is running. So for that version that we just saw, there is a file in there. So there is a file, and it's also important, we have multiple query maps because we have multiple versions of the front end. Every time the front end and the front end engineer decides to change a query in the GraphQL and it redeploys, it creates a new query map. So you see some of these are very different ages. And you can even see the one that I'm currently using is actually a month old, but there are newer versions, because these are newer versions that have been created but not yet deployed. But we still, that's the dev branch I'm on, and they already have newer versions. And if we look into here, if we have internet and look into here, 1 second. If it tries, doesn't matter. If we look into the file, I have it open already. So this is how the file actually looks like. That is our query map. It's a huge JSON file that is basically full of GraphQL queries. And if we search for that ID 12 that we saw before, we know this is called the page config fragment that has a path. And if we go back to our request, we can see how the path was passed in as a variable in here. And we can see even there is a short check, so it actually adds the operation name by itself, just that Drupal can make sure that this is actually the right one, but it also passes in the ID. So we have the ID, and this is basically the whole query. So what Drupal will do, it will receive the query, will look into the query map, and convert the request as it would have been created by that whole query from the very beginning. And you can actually see we're doing multiple requests at the same time. So GraphQL not only runs one request, but it can encapsulate multiple in one. So we have not only the page config fragment of ID 12, but we also have a route breadcrumbs query, we have a route query, and other stuff. So with this, our GET request is super small. It fits into a regular standardized GET request. And then if we, let me shortly refresh that page, as we have intranets now. So we can see here, now we only had a weather query, for example, so there's some weather somewhere on the page, but the response now was able to be cached by Varnish. So we see X Varnish cache hit. So Varnish that sat there was able to cache it, and you can see it's actually quite old. So that means Drupal has never talked to the weather API anymore because the weather doesn't change just that fast. But yes, so now while we click around, so let's say I go here back to the visitor, so this is the page that we saw before. Again, you can see X varnish cache hit with a huge thing, and the response is let me see. Yeah, so it has 10K of data that was cached by varnish that Drupal did not have to create on the backend. Any questions? I know it's a bit complicated, but this is basically so far the only way we find. Yes?
What about public APIs where you don't know which queries may be made?
Yes. Let's talk about security and things like that. So, what we suggest, if you don't have a public API, please disable post altogether in production. You can disable in the GraphQL module, you can disable post request. You can tell it, you can only talk to me, to my API, to my GraphQL API, you can only talk GET requests with query maps. Because this is going to increase the security tremendously. If there is nobody now can just create GraphQL queries to your GraphQL API endpoint anymore. You still want, though, that during development, please still enable post again, because you're going to make your developers' life very, very hard if for every single query change, you need to upload the query map first. That's going to be a pain. So you want to have it enabled in development, because there GraphQL is awesome and it's really cool to figure out, but in production. And maybe disable it on staging as well, so you know before you deploy it if it's actually working. We had multiple times that they deploy something and the whole site goes down, and somehow the query map from the front end did not make it to the back end, and Drupal threw weird errors, stuff like that. So test your query map system. We, as we can run through the deployment process of the hosting environment, the query map generation is fully automated. Like, it's not something that the engineers need to do. You can do it, you can upload it. If you, there's actually the possibility that if a developer wants to run queries against production with the dev environment, that's possible. But usually it's fully automated. But as I mentioned, it is a source of failure. Now let's talk about public APIs. Yes, if you have a public API, like for example our hosting infrastructure runs all via GraphQL. So if you want to redeploy something, you want to know how many hits how much you need to pay, all of that, that's a public API. There you want to allow post. But these requests you probably don't want to cache either, because they are so different between different places. There is a possibility to actually cache post. So Varnish in the newest version, it can cache post requests like anything else. It's completely possible. So you can run posts, so it would just need to be some additional work to figure out how all of that works, or how to teach Varnish to cache post requests. Overall, though, I really encourage you, think about, if you use GraphQL, if you have a public API, think about DOS attacks. Because GraphQL is very easy to say, okay, give me an author, Jamie, give me all the articles that Jamie wrote, give me all of the authors that Jamie wrote, give me all the articles, give me all the authors, give me all the articles, give me all the authors. So with like maybe 10 lines of code, you kick Drupal into making hundreds of thousands of database queries. So there is a way to do complexity analysis on a GraphQL query, and before Drupal starts to execute it, the complexity analyzer says, no, that's too much recursion. I do not execute that for you. So I definitely encourage you, if you have a public API, think about, try to break it, try to attack it, try to create endless loops, or not endless, but like loops that create a lot of data, because it would be very easy. And Facebook, for example, they use query maps as a security feature. You cannot talk to the GraphQL API of Facebook with post in production. You can only talk to them with query maps, exactly out of the reason that they don't want people just to create all kind of their own requests. Does that answer the question? Okay. Any other questions? Yes.
For the website you were showing,
yes.
Is it also doing server-side rendering?
Yes. The site does complete server-side rendering. So if we go here and let's say I visit the first page, so the first page request which just is a get to www.paraplegia.ch. So this is basically talking to this. This is the request. So this system listens to www. This system listens to backend, the website. And the first request, yes, is... Sorry, my Firefox is dying right now. Yes, so the first request is... I don't want to preview. Here. So the first request is a complete rendered HTML, where then you still have JavaScript in there, where we then, the React will boot and it will be a full-fledged React application, but it is complete server-side rendered. So if, yeah?
So the GraphQL GET request made by the browser is made just in case anything has changed in the 1 or 2 seconds between the first server-side rendered GET request,
Yes, so if I click now here on patients, because it never saw the site patients, it does a GraphQL request to the backend, where it tells it, hey, I'm interested in like patient homepage, but if I go back now to the start page, and I go back into the patients, it will start to cache the requests. So GraphQL will not, or the Apollo that runs in there, will realize, oh, I've done that request before, I'm not going to do it again. But you can configure it as you like. Like you could, for example, do still a query to just say did something change or not, but there's a lot of different ways. But yes, it's completely server-side rendered. More questions? Yeah.
So, just a couple here.
Yes, go ahead.
Does the request that contains multiple hash queries, is that cached per query or for that group query?
It's cached for the group query. So Varnish, or I've never seen a reverse proxy that could, like, that understands that sometimes responses are existing out of multiple, except ESI. So there is a system, and I don't want to go too deep, I'm happy to talk about later, but there is a system that you can actually teach Varnish or any other system that it consists of sub-requests, which then again can be cached. But these group requests, they always happen together. Like if you visit the page, you do a group request, but mine is going to be pretty much the same. And over time, yes, you maybe will have situations where the different group requests will end up in the cache all in different fashions, basically. Yes.
Secondary to that, so the hash is a version of some kind, but
yes,
the ID is the specific
correct
query within that version.
Correct.
Right.
Yes.
How many versions do you keep?
So versions is just the amount of queries we have in one single one. So if we go back to this example, so we have here, the lowest number is 28. So that version of the React frontend can run 28 different GraphQL queries. The hashes, or the amount of different of these, which are each of the hashes, we have in the site itself. Does somebody want to count? I don't know, there are probably 50 or 100. Technically, some of them are quite old. So technically, yes, we could start to clean them up, because over time, they will all end up in Drupal as a config. And so yeah, at one point you will gonna have a lot of config files, so maybe cleaning them up is a good thing. But honestly, I don't think that this really adds that much overhead to it for just Drupal to shortly, because it just needs to, the hash is sent in it. Like, it's not like hashing that happens every time the request happens. It's just the request, our GraphQL request, if I can find one, just says, hey, I have version that, and you just go in there.
That makes sense.
Cool. Okay. Now let's go to CDNs. Okay, CDNs, freaking awesome if they work correctly. So overall, the basic idea is that you just replace the varnish layer. So if we go back to our thingy, is we just replace the varnish here and the varnish here with a CDN. Can be done in 5 minutes. You can develop a production. You can go home, no problem. No, not that easy. But I mean, that's basically the idea. So this is how it looks with CDNs. So the user makes a request to the CDN. The CDN has its own cache system somewhere. Luckily, and that's really cool with CDNs, a lot of times they cache it or different CDNs on the same location can share them. So it's a bit better in efficiency. But then the CDN does a request to the Node.js. Now the Node.js, yes, it is probably running, or hopefully it is running at the hosting infrastructure. These are side by side. And now is the big question, okay, do I now tell the Node.js to talk to another external CDN again, which is probably close, but this will gonna add some latency in it, where the CDN then talks again to the latency. So you're gonna basically make a request into your data center, out of the data center, back in. We've done some measuring where the discussion was, okay, does it maybe make sense to have a varnish here instead of a CDN there, or to have a varnish here and here? It really depends on your application. We ended up in just using it that way, and we're happy with it. But there may be some performance improvements, because depending on how much latency your server-side rendering Node.js to the CDN has, it might be a bit slow. But at the end, it really depends on the application. But basically, the request goes to the CDN, the backend CDN then makes it to the Drupal. If now the user wants to talk directly GraphQL, the user talks to that CDN directly. It's the exact same system. And for the perching, it works the same way. So Drupal will then perch that CDN and that CDN with cache tags again. Yes, question.
Does cache tag forwarding between Varnish and an external CDN, is that generally, because it's a standard, generally work?
It's just a header. Yeah, it's pretty easy. I've seen a couple of CDNs that are really reluctant in forwarding cache tags. So make sure that your CDN here can forward them, because if the Node.js doesn't receive them, that one will never know that there are cache tags. So it's a concern. Make sure this happens. But a lot of times you can configure it in how you want it. Like if you use Fastly and you can write your own VCL anyway, in Cloudflare, you can just configure it. But by default, CDNs, if they see a cache tag, they will remove it from the request, like Varnish does as well. Okay, so they need perching as well. Okay, let's talk about pitfalls. So first issue, cache tags, cache header tags can get very fast, very big. And a lot of CDNs limit the size of them, which makes a lot of sense, because it's storage. They need to keep all of that somehow in memory or in files. So if you would just like inject a lot of this. Now, many CDNs, you can change it. Like Varnish has a default size, you can increase it. The unfortunate is that if the cache header is too big, the CDN will just stop answering that request. It's not like, oh, I will pass it still forward to the user and I will just ignore the header. No, it will stop. So we had many cases where we launched a site, everything went well, then on Friday evening somebody decided to change the view from 10 results to 11. That created, the cache header was too big, and suddenly the CDN, or even just adding additional nodes, because as we saw, the ID is in there. So as soon as the ID gets one more decimal, your cache header is too big. So think about that, because it's going to hurt you in the least amount of, or in the worst time. And as said, the CDN will stop handling the request. It will just throw a 5 or 3 and saying, something happened here, I have no idea. And usually the error messages also don't say, hey, the cache tag header is too big. No, it will fail. And then you open a support request at your CDN provider that maybe is only online on Monday again. And you will try to find the CTO via LinkedIn, it really happened, to get a log out of it that then tells you, hey, your cache header is too big. So there's 2 ways. First, you can hash the cache tags. Cache tag, like the cache tags, like node :7 or comment :1700 is quite long. and if you have 100 of them, you easily reach. So there is a possibility that you just hash them. You can get a lot of data in just 4 digits, and so that's a possibility to make them smaller. Or if you know your application very well, you can remove specific cache tags. So if you say, like if you look at the Drupal cache tag header, there's a lot of stuff in there that probably is never changed or doesn't need to be needed. Like even config objects are in there and other stuff. So you can just remove them and say, okay, in my cache headers, I'm only interested in node and comment. So there's a couple of ways there, but be careful with that. Another thing that I just realized that I didn't put in is think about API rate limiting on your CDNs. So the problem is, Drupal, every time a node is updated, it talks to the CDN and purchases and says, hey, node 7 has updated. But sometimes if you change something in Drupal, not only one cache tag updates, but like maybe 100 at the same time. Because so many different places you change stuff. And so we had issues where the CDN stopped for receiving API requests. Because there were just so many, Drupal was bombarding the API of the CDN, and then the API said, no, I do not handle that. So we implemented a whole queue system where Drupal slowly on cron and talks to the CDN. So maybe find a CDN that does it. And the next thing, find a CDN that does not charge you per perch. CloudFront charges you per perch. And so usually if you just do like a front page, if you do URL perching, that's perfectly fine. But with cache tags, you have thousands or 10 or 100,000 of purchases per day. So your bill can explode. Happened as well to us. So please think about all of this. Next, please create CDNs also on staging environments. Do not just assume that you can do them on production. Because something is gonna, like these cache headers or things like that, have an environment where you can test stuff before. And yes, this means in our little example, we now have 4 different CDN configurations, but please go through that, please create it, because you'll thank me later, definitely. There are so many cases that we had issues, or just not problems, the CDN wasn't broken, but just how we used it, it created a lot of issues. And the next is, find a way to put your CDN configuration in code. Find a way somehow that your system configures the CDN automatically, or that you have some kind of versioning of the CDN configurations. We had so many times that something just breaks, or people change something on staging, and then on production it doesn't work the same anymore. And what you do, you open 2 browser windows and you scroll through the configuration UI and compare staging and production, like, is the CDN really configured the same? And so what we ended up with is we found a way that we can put the CDN configuration in code, and every time we deploy, that config is pushed to the CDN. And so with that, if somebody changes a CDN configuration, you know, because it's in code, and then in Git, you know exactly when something needs to be changed. It's a bit hard. There are ways with Terraform and whatever to do all of this. It doesn't really matter what you use, but find a way that you can configure it in code. And the last thing is, think about what happens if your cache hit rate drops to 0. What happens if something causes the CDN to suddenly decide, I'm not caching anymore and I'm passing all requests forward to you? We had a case where somebody went in and changed the CDN config, and we didn't realize, and the cache hit ratio dropped to 0. The infrastructure was fine to handle it for a specific amount of time, but at one point there was so much traffic happening on the actual infrastructure, so the Drupal, that the whole site went down, and then they realized, oh, something has changed in the CDN, and then they struggled to get it back on. So think about 0 cache hit rate. Yes, CDNs are awesome for handling requests and stuff like that, but think about the 0 case. Think about, can your infrastructure handle it? If yes, great. If not, put metrics and alerts it on that cache hit rate. Alert yourself if you usually have, let's say, like most of our customers have like 98% hit rate, alert yourself if this drops below 90 or 80, doesn't matter. Just do something that you get alerted. Because if you try to handle 100% of all traffic on your infrastructure, I'm pretty sure that's not going to work. And at that time, trying to figure out what has changed 4 days ago in the CDN configuration, I can tell you is going to be painful. And it took us almost 24 hours to figure out what exactly is going on. Because at the beginning, you try to find all kind of different. If you would have known 4 days ago that somebody changed something and the hit rate dropped, we would really have known what they changed. So just a small pitfall that cost some sleepless nights for us. That's it. So yeah, caching decoupled website is hard. I think we heard that. But if we do it right, it's quite fast and it's really cool and your customers are going to be happy. Thank you. We have like 5 more minutes for questions. Yes.
First, thank you for the talk. It was very good. Have a couple of questions. Have you observed any delay in CDNs between you issue a Perch until it's actually out of the CDN?
That's where the CDN providers are very, very different. So that's a good point. Test how long it takes for the CDN from where you issue the Perch until it happens through the global infrastructure that it does. They are usually very fast, and that's like a couple of milliseconds, but we definitely had cases where we didn't use one of the Cloudflare, CloudFront, Fastly, Akamai, so the really big ones, more like the smaller CDNs, and there it took 10 to 30 seconds for a Perch to happen, and yeah, this then caused like editors to go and check the site and it wasn't perched and all that stuff. So there are delays, and I would say make sure that you know how long they are and that you know what the implications of that is. Thank you.
That also answers another question, if you have any preference in CDNs. It seems like any of the big ones.
So we tried smaller ones and we tried the bigger ones. And our experience is that the bigger ones usually are better in that stuff. Just because cache tags is still a bit an edge system. It's not fully understood by everybody. Not every CDN supports it. The big ones, they now all do. And in total, if you have a problem with your CDN config, our experience shows that the bigger ones are, usually they had a case already, or they know what you're talking about. While with the smaller ones, we had cache tag issues, and like the case of the header is too big, they never experienced that. And so it took us a long time to actually figure that out. And that's the thing, a lot of times you don't have access to raw logs of the CDN logs. Like, it just fails or it doesn't fail, and then you go into the logging system of the CDN and it doesn't show anything at all. And so then you depend on a good support team that can help you really fast. And so right now we have stuff running on Fastly, Cloudflare, CloudFront, and Akamai. And all of them are good. Each of them has a bit weird things, but that's the ones we mostly use, yes. Any more questions? Yeah.
Do you know this JSON API also includes cache tags and headers?
Does JSON API include cache tags?
Yeah.
It's a Drupal default. Like it's not something that the system really needs to do. It just needs to put them into a header. But Drupal itself handles all the bubbling up of the cache tags and handling them, and if you have a module that can like take them and change them, like what we do for the hashing, should work with all the systems. Other questions? Yeah, that's it.
Have more questions. I wanted to let others. So, have you experienced any improvement or any benefits on cache in header compression using HTTP2, or to shorten the length of the?
I don't think we've tried that ever. That's an interesting thing. I'm not sure though if the CDN. So you mean to be able to put more cache tags into the CDN, or just to be faster?
To mitigate the problem of we have too many tags, or the header is too big. HTTP allows you to run a compression algorithm on the headers. So.
But I'm not sure if the storing of the header then is uncompressed. But yeah, we've never tried. Yeah, no, we have never tried. No, we have never tried.
One question.
Yes. Oh, sorry.
Have you given thought to pre-computing the query map ahead of time?
That's what we do.
Oh, so you basically run the results. Results are basically ready.
Yes. Yes. So I can shortly show that. So the app. Yeah.
How do you deal with dynamic parameters? Or do you not allow that?
So there is basically a yarn script or an npm script that runs that update persistent GraphQL, and that happens during build time of the application. So before it runs.
Oh, I see.
Yes, it always runs.
So your solution does not allow the client to pass dynamic variables.
No, you can, but they are defined. So for example, for that. Let's look at one of them. So this is route query here. So it says route query of that version, and that's the ID number 14. So let's look at the route query. So if you search for route query, we can see that. And the route query obviously needs the path, like it needs to know the path. So the path is injected as a variable in GraphQL. So GraphQL has a possibility to inject variables and reuse them inside the query itself. So the variable path here is going to be used by all kind, like by route, by path, and probably also in other places. No, not, but it's basically used in here. So that's the dynamic part. This is why we only have in total 28 different GraphQL queries, while we have thousands of nodes on that site, or thousands of paths in that site. And yeah, no, that would be a very big query map if you tried to create it without the variables.
Cool, thank you.
All right, I think that's it. Thanks a lot. Have a good one.